welcome to another Sidewalk STEM. I'm Dr. B here at the East Lansing Public Library. And you did not interrupt some problematic math. No, I'm just getting some paper ready for today's demonstration. This is one that you can pretty easily do at home, and it's kind of neat. And so as we enter into these dry, wintry months, the air outside is drier, especially in our houses and apartments where the furnace might be running and drying out the air even more. You might encounter static electricity a little more often. So as you walk across the floor and go to touch a metal doorknob, you might get a little bit of a shock as that static electricity discharges across the gap between your finger and the doorknob. And so we can actually do a pretty fun, kind of neat experiment to demonstrate some of the properties of electrostatic charge. So I'm taking some paper like this. I have some of this yellow legal pad paper, but you could use kind of any paper at home, maybe napkins or printer paper, coloring paper, tracing paper. Might be a really neat scientific comparison to see how different kinds of paper react. And you're going to want to tear it up really small so it can be kind of cathartic as well. So we'll tear it up into tiny bits. The tinier the better. I'm going to get mine nice and small here. I'm going to leave some a little bit bigger too and see if they react differently. And that might be enough for our purposes. So I'm going to take something plastic, like this ruler here, and I'm going to rub it with some wool. I actually have a piece of fabric wool here, but you might use a wool sock or a wool sweater. And you can try different fabrics as well. And I'm going to hold the ruler down at the end, and then I'm just going to pull the wool without touching it with my fingers anywhere else. Just kind of wrap this around. I'm going to do this. And so what's happening is we're actually electrically charging up the ruler. The plastic is taking a lot of the electrons from the wool, and it's actually holding onto the ruler. So we're giving the ruler a negative charge now as it collects those extra electrons. And so we can see this, not with our eyes, but we might be able to see with the reaction. So I'll bring you in here, and we'll bring this ruler now down to these tiny bits of paper, and we'll just see what happens. Whoa! So you can see some of the paper is starting to dance, bounce up. Some of it's even leaping off of the table as it appears, and actually sticking to the ruler. That is so cool. Look at that, and I can try and shake them off, but some of them are pretty persistent, stuck onto there. So you might wonder what's happening. It almost looks like there's a magnetic charge between the paper and the ruler. And it's actually an electrical charge, and it's kind of like a magnet. So with a magnet, you probably know that opposites attract. So in a magnetic field, the South Pole and the North Pole, they'll actually stick together, while two South Poles will push apart, and two North Poles of the magnet will push apart too. So with an electrical charge, a positive charge will attract a negative charge, but like charges will repel. So this ruler, we made it have a negative charge by letting it steal electrons from that piece of wool. And when it had a negative charge, we brought it down to these tiny little bits of paper, which were neutral. And the negative charge of the ruler actually pushes some of the electrons away from the paper, and that gives it a slight positive charge. And once it's got that, that positive end of the paper can kind of point up and even jump up and attach to the ruler when it has that strong electrostatic charge between it. So I don't know, I always think this is a really fun, simple demonstration. And you can try this at home using some things that you might have as plastic, like rulers, combs, maybe a plastic spatula, and then fabric. And you just kind of rub it across to see if you can give it a little bit of a static electric charge there, and then try it on different kinds of bits of paper. And you can see if you can get a little static electric charge like that as well. All right, well, thank you for joining us this week. Hope you stay warm, and I will see you next time for another Sidewalk STEM. Bye, everyone.